So the sum of two cubes, that's in 13, actually that's the appendix. So appendix, here's appendix 1. Okay, appendix 1. So on page 1223, okay, so we're gonna talk about the sum of two cubes this time. So remember, the difference of two cubes look like this. So that's where you had something like f cubed minus l cubed. And remember how we factor that? How'd you factor the difference of two cubes? Was that binomial times a trinomial? What does that binomial look like? F minus L. And what does a trinomial look like? F squared plus FL plus L squared. Okay? The sum of two cubes is the same idea. So you'll have F cubed plus L cubed. It is still a binomial times a trinomial. It's a binomial times a trinomial, just like this one was. So in the difference of two cubes, when the binomial is F minus L, what do you think it is for the sum of two cubes, a binomial? F plus L. And notice the first term is the same in both. So you're going to square the first term. Now, when you go back to the difference of two cubes, you see how in the binomial that was a subtraction right here? Mm-hmm. And we look at that second term, it's a addition. Yes. When you factor the sum of two cubes, see how this is addition? Mm-hmm. And this is going to be subtraction. So everything's going to be the same except for these two. So all these, both of these formulas look the same except for the sign. So there'll be F squared minus FL plus L squared. All right, now let's look at number okay, let's do number 14. All right, 14, you have 125 plus r cubed. 125 plus r cubed. According to that flow chart, and based on what we've been doing, what's the first thing you're going to look for? The what? The GCF. GCF. What's the GCF here? It's 1. So then you ask yourself, how many terms are there? 2. So look to see if it's a difference of two cubes, the difference of two squares, or the sum of two cubes. It can't be the difference because what's the sign between them? Positive. Addition. So the only thing you can think of then is the sum of two cubes. Now it could be the sum of two squares, although it's not because r is being raised to what power? Third. So you want to check and see if this is the sum of two cubes. So just like we've been doing, you want to try and fill in these parentheses. What goes inside the first parentheses? 5. What goes inside the second parentheses? R. So F is 5 and L is R. Once you fill that part out, then you use your formula. So my answer then is going to be, what's the binomial? 5 plus R times, and then the trinomial says I take F, which in this case is 5, and I multiply by itself. What do I get? 25. So that's my first term. So it'll be 25 right here. Now, is this going to be 25 plus or 25 minus? Not plus, it's minus. Okay, minus. And then the second term is where I take F and multiply by L. What's F in this case? And L is R, so that's 5R, right? and then plus, and then L squared. So I take L multiplied by itself. L in this case is R. What's R times R? R squared. So there's your answer. So you factored 125 plus R cubed as the difference as the sum of two cubes. There's binomial, then there's trinomial. Let's look at okay, so let's look at this one. This is okay, so this is number 16. You have 54 R cubed plus 2. 54 R cubed plus 2. Say it again? GCF is 2. So first of all, you're going to do what? Factor out the 2. So 2 times what? 27 R cubed plus 1. Okay, is that my answer? No, you got to look at that parentheses and see if I can do anything else to this binomial. What do you think that is? What do you think this is? Sum of two cubes. So let's check and see if it is. What times itself 3 times is 27R cubed? 3R. What times itself 3 times is 1? 1. So there's your F, there's your L. So my binomial then is what? 3R plus 1. Okay, now let's talk about the trinomial. Okay, so the trinomial, the first term is, remember, the first term right here is F squared. So F squared means F times F. What's F in this case? 3R. So what's 3R times 3R? 9R squared. So that goes here. 9R squared. Now, is that 9R squared minus or plus? Minus. Then the second term says I take F multiplied by L. Well, F in this case is 3R. L is 1. So what's 3R times 1? So that goes here. And then plus, and then the last thing I got to do is square L. So L squared means L times L. What's L in this case? What's 1 times 1? So there's your answer for that. Now be careful in the blank. Remember, this is the answer to this. But that wasn't the original problem. The original problem, you factor out a what? A 2. So your answer has to have a GCF of 2. So what's the answer? Times 9R squared minus 3R plus 1. Okay? All right. Okay, let's look at 15. You have 8R cubed minus 64. 8R cubed minus 64. 8 is the GCF. Okay. So you can factor out an 8. So you get 8 times what? Minus 8, right? So let's go off to the side and kind of figure out what, if I can do anything to R cubed minus 8. What is that? Difference of two cubes. So inside the parentheses, I can fill in those parentheses. That's an R here, and this is a 2. So there's your F, there's your L. And so r cubed minus 8 is a binomial times a trinomial. The binomial is easy. What's the binomial in this case? R minus 2. Okay, and then the trinomial is f squared. F squared means f times f. What's f in this case? So what's r times r? R squared. Now, is it r squared plus or r squared minus? R squared plus this time. And then the second term is f times L. What's f? What's L? So r times 2 is 2r. And then plus L squared means L times L. What's L? What's 2 times 2? All right, so there's your answer for that. But remember, there was a GCF of 8, so what's the answer?
8r minus 2 r squared plus 2r plus 4.
Okay. Now, that same problem, some of you are not careful and you don't think about the GCF right away. But if you look at 15, right off, the way it looks, it is the difference of two cubes. Because I can write 64 as what times itself 3 times? 4. Okay, so I want to show you what you're going to have to do if you don't take out the GCF in this case. Now, in number 16, you had to take out the GCF right away because 54 is not a perfect cube. No whole number times itself 3 times 64. Same thing for 2. So you had to take out the 2. But here, some of you can think of looking at 8 and say, well, that's already a perfect cube. 64 is a perfect cube. So what you would have is this. You would say 2r times itself 3 times is 8r cubed, correct? What times itself 3 times 64? 4. So there's your f and there's your L. So you get this binomial times this trinomial. What's the binomial? 2r minus 4. All right, let's talk about the trinomial. The trinomial is f squared, meaning f times f. Okay. F times f. What's f in this case?
2r.
So it's 2r times 2r. 4r squared. Now is it 4r squared plus or 4r squared minus? Plus. The second term is f times L. What's f?
2r.
What's L? What do I get?
8r.
8r. And the last term is L squared, meaning L times L. What's L?
16.
4 times 4 is 16. Okay, so that's where I'm at. Now, if you're not careful, you're going to say that that's the answer. But remember, we talked about this before, and you'll notice in the flow chart it says this. Check each factor. Can it be factored again? Okay? So if I look at this factor here, 2r minus 4, can I factor it further?
Yeah.
Yes. What's the GCF in this binomial? 2. So I can factor out a 2. Look at this factor. Can I factor it further?
Yes.
Yes. I can factor out a what?
4.
A 4. And then all you got to do is rewrite the 4 times 2 as 8. So the answer is 8 times r minus 2 times r squared plus 2r plus 4. Okay, but it's always easier to deal with the GCF at the beginning than it is to wait until the end. Okay. All right, and then this is number 20. So number 20, did we do number 20? I don't think so. Okay, no. Number 20, you have 8t cubed plus s cubed. 8t cubed plus s cubed. Okay, sum of 2 cubes. The GCF is 1. What's the first parentheses?
18 plus F.
Nope. What's the first parentheses? Nope. What? 8 times 8 times 8 is not 8. 2t. What's the second? S. So there's your F, there's your L. And it's just a matter of you taking that, putting it into your formula. So then the answer, since the GF is 1, whatever we put here is going to be the answer. What's the binomial? 2t plus s. All right, let's talk about the first term of the trinomial. So that's f squared, meaning f times f. What's f? F is 2t. 2t times 2t is 4t squared. Now it's just 4t squared plus or 4t squared minus? Minus. So then you're going to multiply f and L. F is 2t. L is s. So I get 2st. So we tend to put it in alphabetical order. You can write as 2ts if you want to, but we just tend to put things in alphabetical order. And then plus, and then L squared is L times L. What's L? What's S times S? So there's your answer. Okay. Okay, number 11. You have 24x to the fourth minus 81 xy cubed. 24 to the fourth minus 81 xy cubed. What are you going to do? GCF. What's the GCF? 3x. So GCF is 3x. 3x times what? Minus 27y cubed. Okay. Is that the answer? No, let's take that binomial and see if I can do anything with it. What do you think you can do with it? Difference of two cubes. What goes inside that first parentheses? What times itself 3 times is 8x cubed, 2x. What times itself 3 times is 27y cubed, 3y. So there's your F, there's your L. So your binomial then will be what? Yeah. All right, now let's talk about the trinomial. So the first term of the trinomial is f squared, meaning f times f. What's f here? 2x. So 2x times 2x is 4x squared. Is it plus or minus? Plus. So then I take f multiplied by L. What's f? What's L? So what do I get? 6xy. And then finally L squared, so plus L squared. So L squared means L times L. L is 3y. So what's 3y times 3y? All right, now be careful. Don't just put that in your answer because you had a GCF of 3x. So it's 3x times this.
Professor Michael, so we're basically breaking it down as small as we can, with it being a binomial. What's the first term called right here, and then the
This?
binomial and then trinomial.
Yes.
That's what we're doing.
That's how you factor the sum and difference of two cubes. A binomial times a trinomial. All you're doing is using a formula.
Okay.
Okay? So whenever you factor the difference in the sum of two cubes, it's always going to be a binomial times a trinomial. And you're just using these formulas that we talked about. Right here. Okay, now, let's do one more. So this is, let's see. Okay, so let's suppose we had there's one worksheet that all right, so let's do this is number 78, and that's on page 996. Okay, so here's the problem. N to the 9th minus n to the 5th. So what are you going to do?
Factor out into the fifth.
Yeah, the GCF is into the 5th. So I'm going to factor out into the 5th. So it'll be into the 5th times what?
And into the fourth.
Into the 4th. Because remember, when you multiply like bases, you add exponents. So into the 5th times into the 4th is into the 9th.
Minus one.
-1. All right, so that's where I'm at. Is that the answer?
No.
No, because if you look at that into the 4th minus 1, what do you know that is? Difference of two squares. So in other words, I can write this as something squared minus something squared. The last term is easy. What times itself twice is 1? 1. Now what about n squared into the 4th? N squared times n squared is into the 4th. Okay? So there's my F, and there's my L. Now remember, that's the difference of two squares, though. So the difference of two squares is F minus L times what? F plus L. That's the difference of two squares. So if F is n squared and L is 1, then I can factor this as what? N squared minus 1 times n squared plus 1. So that's where I'm at now. On one of your worksheets, you had one similar to this that we're looking at right now. Am I done with this? No, because if I look at this parentheses right here, that is still what? But the difference of two squares. This is called what? Sum of two squares. Can I factor the sum of two squares? No, but can I factor the difference of two squares? Yes. So that means I can take this one and go further with it. So what's n squared minus 1?
N minus one.
Times?
N plus one.
And then you just bring down the sum of two squares. Okay? But be careful, don't say that that's your answer because you also had a GCF of n to the 5th. So the answer then will be n to the 5th times these three factors. N minus 1, n plus 1, n squared plus 1. Okay, so that'll be your answer. So there was one problem on one of your worksheets that you had to go further with it like that. Okay, and this is 77. You have x to the 6 minus 81x squared. What's the GCF? X squared times
X to the fourth. Minus 81.
okay. Now remember, you got to take that x to the 4th minus 81 and see if you can do anything else to it. What do you think that is? Difference of two squares. No, it wouldn't be the difference of cubes. You get that exponent of 4. So let's try the difference of two squares. What times itself twice is 81 though? Okay, that part's easy. Now let's look at x to the 4th. What times itself twice is x to the 4th? X squared. So how do you factor this? x squared minus 9 times x squared plus 9. Okay, can you go any further with any of these two factors? Yes, which one? First one, because that's a difference of 2 squares still. So how do you factor that? Not x minus 9,
3.
x minus 3 times x plus 3. Times what? Okay, y'all agree with that? Okay. Oh, yeah, but that's not the answer, right? So the answer, you have to put that GCF in it. So what's the answer?
X squared, x minus 3, x plus 3, x squared.
Okay. All right, so that's all you do there. Okay. All right, now, we're still doing factoring. Everything we're going to do for the most part for the next month or so will involve factoring. But let me just show you what worksheets I need to give you.